Hi, Algebra 2 students. Today we're going to move on with 13.3 trig functions of any angle. What I want to take a look at first is, this is actually from your book. It is the definition of a trigonometric function. So these are things you already know. And what I want to do is relate it to what you see here looks like a unit circle, but this doesn't just have to be the unit circle. It could be any circle of radius r. So if I give you an angle theta, remember theta is from standard position to the terminal side, we can come up with these trigonometric functions. All we need is the side opposite, or the y value, the side adjacent, or the x value, and then the hypotenuse, which again, for this one, is going to be the radius of the circle. So if I called this angle right here, whoops, need my pen, hold on. If I look at this angle right here, okay, and I'm not going to call it theta, let's just call it, I don't know, angle Q for something different, okay. So this side right here for angle Q would be, this is the x value, and this would be the y value, and this would be the r value, which is right here. So sine would be opposite over adjacent, or excuse me, opposite over hypotenuse, or y over r. So you see over here, opposite over hypotenuse. It's nothing different than what you already know, it's just presented in a different way. Cosine is adjacent over hypotenuse. Okay, so for what you already know, adjacent or x over hypotenuse r. And same goes for all of your other trig functions. Notice here that when we get to the tangent through cotangent, we can't divide by 0, and that's why these all say can't divide by 0. So tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. And that's where we have these x, y, and r. Okay, so you're going to see some of this coming up, and I just want to relate it to things that you already know. No need to memorize x, y's, and r's. Go with what you know. Alright, let's look at an example. So let -4, 3 be a point on the terminal side of an angle in standard position. Evaluate the 6 trigonometric functions of theta. So the first thing we want to do is draw this point. We know that -4, 3 is in quadrant 2. So 1, 2, 3, 4, up to 3. Here's the point, -4, 3. So a point on that terminal side. Okay, so here's my angle theta. Well, what I'm going to do, come over here, is make my triangle, because if I want to evaluate these, I need my triangle. So I'm going to make my triangle here. This side we already know is 3. This is -4. Okay. And then I need my r, my radius right here. Remember that I can use Pythagorean theorem, 3 squared plus -4 squared equals r squared. So 9 plus 16 is r squared. 25 is r squared, so r is 5. So r equals 5. So now I need sine, cosine, all of that. So sine, okay, of theta, cosine of theta, tangent of theta, and remember with sine matches cosecant of theta, secant of theta, and cotangent of theta. So now here we go. We have our angle right here. So sine is opposite over hypotenuse, so 3 over 5. Cosine is adjacent over hypotenuse, and notice that I'm taking the sign with it. The sign indicates that I'm in quadrant 2, negative and positive. Tangent is opposite over hypotenuse, so 3 over -4. Uh-oh, come back. Okay. Cosecant would be hypotenuse over opposite, so 5 over 3. Secant is hypotenuse over adjacent, so 5 over -4. And cotangent is adjacent over opposite. So this looks different, but it's something that you already know. All right, let's do it again. Today in class we studied about the unit circle. Okay, use the unit circle to evaluate the trigonometric functions of theta equals 270 degrees. Okay, well in class today we learned where, first of all, unit circle has a radius of exactly 1. Hopefully you were saying 1. So here I am at 1. Okay, 270 degrees is over here. So let's talk about my x value, my y value, and my r value. So x would be 0, y would be -1, and r equals 1. Again, r is 1 because radius of unit circle is 1. That's how I knew that. And that's it right there, unit circle. All right, so here we go. Sine of theta, cosine of theta, tangent of theta. Then we have cosecant, secant, cotangent. All right, so sine is opposite over adjacent. So now what do we do if there's no triangle? Okay, so we might have to go back and look at those from the first slide right here. Opposite is the y value, okay? Adjacent is the x value. So we could write next to that, this would be opposite, this would be adjacent, this would be hypotenuse. Okay, so sine would be opposite over hypotenuse, or -1 over 1. Cosine, adjacent over hypotenuse, so 0 over 1, which is 0. Tangent would be opposite over hypotenuse, opposite over adjacent, so -1 over 0. Can't do that, can't divide by 0, so that would be undefined. Cosecant would be hypotenuse over opposite, so 1 over -1. Secant would be hypotenuse over adjacent. Same thing, can't divide by 0, so it's undefined. And cotangent would be adjacent over opposite, which is 0. So reminder, we can't divide by 0, those are undefined. 0 on top gives you a value of 0. All right, the next thing we want to look at here is the idea of the reference angle. Okay, it says let theta be an angle in standard position. The reference angle is the acute angle, they're defining as angle prime, formed by the terminal side and the x-axis. The relationship between theta and theta prime is shown for non-quadrantal angles theta such that 90 degrees, theta is between 90 and 360 degrees. What does that mean? Okay, that just means that you only have reference angles in quadrant 2, 3, and 4. Okay, so it is the angle formed by the terminal side and the x-axis. Well, in quadrant 1, those are all your regular angles. So here we go. Let's process what that means. For an angle theta here, starting at the initial side, going over to the terminal side, okay, that would be the angle theta. This is the reference angle. Okay. For an angle going from the initial side over to the terminal side, okay, the angle formed between the x-axis and the terminal side, this is the reference angle. Again, an angle starting in standard position going over to the terminal side, okay, the angle formed by the terminal side and the x-axis, this is the reference angle. Okay, and you see down here some formulas on how to figure out if you add or subtract from 2 pi or 180 or in radians and degrees. We'll do some practice to make sure you feel okay with that. So here we go. Find the reference angle for the following angles. I have the angle 5 pi over 3. Well, first let's draw 5 pi over 3. Uh-oh. Oh no. Sorry. The computer's crazy. Here we go. 5 pi over 3. So where is that angle? Well, we know this would be 3 pi over 3, or pi, okay, plus another pi, because this is 1 2/3 pi. So that puts us down here in quadrant 4. This angle right here, 5 pi over 3. You can also use your unit circle to help you locate which quadrant 5 pi over 3 is. So if the whole circle is 2 pi, what's left for this piece right here? That's what we're looking for. This is our reference angle in red. So 5 pi over 3 plus what gives you 2 pi, or we can go in reverse. 2 pi minus 5 pi over 3 with a common denominator, that is 6 pi over 3 minus 5 pi over 3, which means that our reference angle is pi over 3. That is the measure of that reference angle. Let's try again. Okay, theta equals negative 130 degrees. Well, that means that we go clockwise 130. This would be going clockwise negative 90. This would be negative 180, so we're in here. This would be negative 130 degrees. So what we're looking for is this angle measure right here. Okay, so we have this whole angle has to make 180 degrees. If I've already gone 130, that means my reference angle here is 50 degrees. All right, let's do one more. My goodness. Sorry, my computer is crazy. Here we go. One more. If I have 15 pi over 4. So 15 pi over 4, well, where's that going to be? 4 goes into 15 how many times? It goes in there 3 times with 3 left over. So if I'm going 3 pi, well, that's 1 pi, 2 pi, 3 pi, okay, so 1 pi, 2 pi, 3 pi, and then 3/4 more is going to put me right here. So this angle right here has a measure of 15 pi over 4. Well, to get to here, that would have to make me go to 16 pi over 4. So 16 pi over 4, which is 4 pi, that would be around the circle completely twice, minus 15 pi over 4 will give me a reference angle. Let me change colors for you. Of pi over 4. Sorry about the computer issue. So my reference angle here is pi over 4. Okay, guys, so here is your video examples. 2, like we did with the angle, and on both of these you need to find r. Okay, notice here -5, -12 is going to put you in quadrant 3. 3, -3 is going to put you in quadrant 4. Find r first, and then some reference angle practice. Thanks so much for watching my video.